very excited to have a deep conversation with Ivan. Ivan is the co-founder of Cohere alongside Nick and Aiden, and he oversees the key technical product development and is closely involved in the company's public sector and government customers. But maybe even more impressively and importantly for this audience, he is also the co-founder of For AI movement, and which turned into Cohere for AI after a few years, and which is now what we call Cohere Labs. So really good to have you here, and I want to hear, and I'm sure everyone wants to hear more from you. How are you?
Hey, I'm happy to be here. I'll continue the tradition. I'm in Ottawa. There's snow on the ground, and it feels like -5. So Ottawa, Canada.
Oh wow. So that's yeah, I'm not gonna complain about like in Amsterdam now, I think it's like 4 degrees. Like it's not it's not too bad. But I love to see some snow this year. Yeah, it's been a while. Yeah, great to have you, Ivan. So I want to start off by just asking you about the early days of 4AI and really what sparked this. Before it was really cool and this buzzword of collective work, working in a community on research. What really sparked that and how did it start?
Yeah, great question. So for me, it's always fun to think about those times because it was a much simpler time in the ML space for sure. In 2017, I was sort of mid-career in my like software engineering journey. At the time, I've only worked on like back-end systems, write and go, like worked on products. And there was an opportunity to work with Aiden, who at the time I had no idea, it was pre-Transformers, so who's Aiden Gomez anyway? Don't tell him I said that, but really it was curiosity driven, right? Like so Aiden had the idea to start a lab. He wanted to publish some papers, and he sort of blasted this message to the U of T, University of Toronto Computer Science community, where he was looking for other collaborators to just independently work on some papers together. And at the time, you could get away with, one or two GPUs to run enough experiments for your papers. And so it was a plausible, endeavor. And so I was curious about AI. I had some exposure to it. I certainly knew, one of my first programs was like a chess AI, right? And that was with like mini max algorithms and stuff like that. And so neural nets were pretty interesting to me, sort of mid-career. And so, it was curiosity driven. I wanted to learn something new. It seemed like a fun thing to do after work. And so we linked up and started working on for AI.
And how was so I guess you were at the University of Toronto, so that makes sense to launch it there. But like, how was the experience of working, like starting this in an academic setting with really like research-driven minds?
Oh, it was totally independent. So nothing like
Oh,
U of T had nothing to do with it, to be honest. It honestly started on Slack. Like we had this
oh.
like free version of Slack for all of the department, like all the students and stuff like that. And we just started working together. He ran like a trial process to, weed out who's capable enough to contribute, which is I think we were all building autoencoders in TensorFlow. And yeah, it was just like there was like a cohort of like 15 people. We all like ran through the exercises. We like, eventually trickled down to like maybe 4 or 5 collaborators after that. And then we would meet up in the same building where Jeff Hinton's lab was. And I think Aiden was working with Roger Gross at the time. And so he had a desk there, and so he hosted, the survivors of the autoencoder TensorFlow exercise, and we would meet there and just discuss some potential research ideas. Um, and yeah, like I think we landed on a few. Like we thought a lot about like computational like atomic computations, right? Like addition, subtraction, and then there was like, and then Psychogans had just released, so that was like the most hyped thing at the time. And so it captured all of our attention. And so we were like, oh, what if we applied the same concept? So CycleGAN was like you take two GANs and they try to like trick each other on how to best create images of two classes. So the paper itself, they did like I think it was pictures of horses and zebras, and they would like try to trick each other by generating good pictures of horses and zebras. And so we wanted to take that same concept and apply it to language, so text, which is very different, right? Like obviously images is a more continuous space, and text is more discrete, and so we need to solve for how to do this in a discrete space. And so that was super fun. And it didn't take that much compute to start with, right? I mean, at the time it was a lot of compute, but we were very scrappy. We were, after work, right? After our day jobs, we would meet at U of T, not in a sanctioned environment, not a sanctioned program whatsoever. And there was some free compute lying around. And so maybe we would do a training job here and there to support the results we needed on the U of T cluster. Thank you for that. And so yeah, I mean that's really how we got started. We just decided to do it. We just decided to do the thing.
Yeah, I love that. Actually, 2000, you said 2017, was it?
Yes, this was yeah, like
Yes,
2016, 2017 era, right?
2017.
This was
Yeah,
like pre
that's
yeah,
actually,
GANs were like the thing, right? This is like
yeah,
when Ian Goodfellow had that like incident with yeah Schmidt Huber. That was that era
yeah,
of
the
ML.
famous Nurips
Yes,
panel.
exactly.
Yeah, I actually that's funny you mentioned trying to do this cycle again in replicate that in language. 2017 I was in the middle of my PhD, and it was the time that neural networks in computer vision, they showed a lot of really nice promise in the beginning of getting that into language. And one of actually my first paper was inspired by data augmentation techniques in computer vision, applying that to language, and how similarly with vision it's always really, well, relatively easy to you don't use semantic meaning by flipping an image or like blurring it or like making these modifications, but with language it's a whole different story. And kind of I feel like that was also around the time that generally research began to like different fields began to merge together, and in these
Mm.
interdisciplinary, like getting inspired from one field and do that in another field, and that kind of ends up where we are now, that we have this really one architecture and one model that can do all of that.
Yeah, honestly, it's so different back then compared to now, right? Like back then we had different neural nets for different modalities. Now you have sort of these omnimodal architectures. It's super exciting to see. Yeah, it's just
Yeah,
information at the end of the day now.
yeah. I do want to ask you about this because that was also the area that toolings were not really, in terms of also like everyone switched from Lua to Torch to PyTorch to TensorFlow, like every year was something different. And the community driven work to improve each of these and share the learnings was really important to what becomes now, I think, how like PyTorch for the most part is now dominating this technology. And how much of that, like how much of this like learning together something new that no one else knows how to get that to work was uh, maybe you think was possible through this like for AI community, and maybe couldn't have been done in another way. So just like motivated people just pushing to learn to get things working.
Yeah, I mean, look, I think at the time, right, like TensorFlow at the time felt developed, right? It felt like, oh, they've already solved machine learning, they've already solved all these training problems. But as we see now, that's very much not the case. There was so much more innovation and frameworks and technology built on top of it. Even if we moved to JAX, right? We moved to PyTorch. That's how the ecosystem evolved. So I think every generation of technology, there's like so much more that could be optimized or improved upon. The constraints we had at the time was like resources, right? Like we were a small lab, independent, and so we had a very specific problem set, but we had a very different skill set as well. So I came in with my background in software engineering and managing infrastructure. I was able to build tooling using my skills for us to better manage our experiments, better manage our compute clusters. And so you just have to be creative, right? And again, if you're doing independent research, you need to be scrappy. Use whatever's already built, just use that, right? And if it's good enough at solving your problems, but then focus your differentiators on the differentiating stuff, right? If you're particularly good at some sort of tool set or language, like you could use that to build a really great eval for that space, or construct tooling around that area so that your research could be better there. But really, you have to have that like grit to just like keep trying things until it works. I think that's really I've seen so many independent labs throughout my journey in ML, and the ones that survive really is just some like ungodly amount of determination to make it work. And I think that's really the difference maker. It's not like your backgrounds or whether you have a PhD or anything like that. It's just successful research is done by people that don't give up.
Yeah,
So
persistence, perseverance, definitely. I agree. And then I'm curious because so after 4AI, you started Cohere, but then what was still like stuck with you, and also Nick and Aiden, that you made you go back to creating Cohere for AI at the time and now Cohere Labs? So like what memory that you wanted to follow from the early days of 4AI, and what was really the main goal to start this research lab?
yeah, I mean there's obviously like the like business reason, which is like it's great to have a vector to deliver research in a way where we can still collaborate with other companies. It's so therefore it had to be independent, and we could still publish some of the work that we do for to innovate for our customers. But for Aiden and I, we really wanted to pay it forward, right? For Nick, Aiden and I, we want to pay it forward to back to the community because for us, for me in particular, right? I mean, Aiden obviously he had Google Brain, he had Oxford, and all these great pathways to ML, but for me in particular, I was really an outsider coming in to machine learning. I had really no reason to be there, like truly. I dropped out of school. I dropped out of undergrad. I was a software engineer. I had no training whatsoever in math and ML. Actually, I dropped out before I even took the ML course at U of T, which is interesting. Um, but I really had no reason to be there. But it really, I feel like I'm the existence proof for, hey, like given the right environment, the right support, the right access to resources, I was still able to be useful, right? Like I could still find a way to be useful in the research environment. And so part of it was, yeah, like let's pay it forward, right? Like I was supported by many mentors and systems along the way to support us. So Google, for example, they supported us with the research cloud, right? So 4AI was one of the first external users of the TPU, right? And then Cohere became that as well. So and then, of course, U of T and Vector giving us spaces, giving us mentorship. A lot of profs along the way gave us that. And so I was lucky enough, like me personally, I was lucky enough to find that pathway into ML, and I was able to contribute massively. And so 4AI was a way for us to manufacture that luck. So could we find others like me who might have never gotten to ML if there was no pathway in, and then like I couldn't have built all this cool stuff. And so yeah, well, I wanted to pay it forward, and I wanted to have a vector for you come from an untraditional background, you could potentially be useful for ML. Let's explore that connection. Maybe there's a connection there, and of course it's been successful, right? We've had so many scholars and people from the community who ended up actually joining us full time and contributing massively to our architecture.
Yeah, one thing we are really proud of is just trying to find these like diamonds people around the world, really globally, who just need that initial help and boost to make the connection, and they have this really this fire inside them that we see how in the research that we work with them, in the scholar projects, in community projects, how they really do things that no one has done before. And then we also they join Cohere and they make huge difference in the teams that they join. So it's really great that this is and it's also part of what I'm very proud to be part of this lab and really proud to work with these people. I do want to get your thoughts on right now with this, especially with this sort of like this global research ecosystem that we have in this community. What do you think are interesting research questions that people should be thinking about? And also, it can be like what is a little bit maybe overhyped and like maybe something else that are underappreciated that more people should be working on.
Yeah, I mean, top of mind for me is like, I think we've solved, I think there's been a lot of progress made on the generalization of the transformer. I think you can build like pretty decent agents now, but there's probably still some more work to do to like understand agents better and make sure that, they work well in a production setting. And so that's things like research on the harness, research on prompt engineering, research on like, is MCP like the best way to present, a way for the model to feel the environment around them. And then of course there's, yeah, if I didn't mention evals already, evals are the most like difficult problem right now because nobody wants to build evals, but also they're probably like the first thing you should do before you start constructing an AI system. So agents is very interesting to me, and then also applying the technology to different like domains is also very interesting, right? Like, yes, they're generally useful, but like, how good are they at cybersecurity? Like, how good are they at sciences? How good are they at like, doing like chemistry, right? And can we figure out what are the paths that we need to discover and research for this, AI agents architecture, with transformers maybe to do really great chemistry, right? And again, it starts with the evals. So I think a great, set of problems I want to see solved is like, the labs, us, right? Like, and some of the other labs, we've built this intelligence that's, we've tried to build this very general intelligence that's like smooth across the board, but evidently it's very jagged, right? If you look at what AI agents are like today, like they're very good at particular things and very spiky in performance. But it's very much not that general yet. And so as a research community, like I challenge the research community to give us better evals to understand the jaggedness better, right? So having even just better visibility over where the spikes aren't, um, and then potential techniques to solve for the jaggedness.
No pressure for everyone, but yeah, so solving the eval problem. Yeah, it's very much, I agree. I do think so really going beyond with evals, measuring individual metrics and numbers, but really this out of distribution, real world performance and behavior understanding of the models. Easier said than done. And it is kind of a catch-22. If you already have that, you already probably can design the model for that as well. Uh, but I think that's a nice, I definitely agree that it will, creating new evals will shape where we set the next milestone and we all move towards that. So like we should be thinking about what is important and where we want to get, and then designing the eval to measure the progress there. Yeah. And I do know you have also work closely with on the policy side, and you mentioned also this like the societal impact of this technology. And I want to hear your thoughts about how do you think, especially community-led research, can have an impact on policy and societal outcome of this technology?
Yeah, I mean, especially important for community members in developing nations, right? Like there's really like the governments need our help uh to learn more about the technology. Like it's moving quite fast. And so I see the role of key experts around the world. Uh, hey, volunteer your time to actually advise the government, like whatever that means for you, right? Like whether that's reaching out to like your local representatives or like seeing if there's national AI efforts to sort of solicit this kind of advice. But really, like the risk to bad AI policy is from ignorance, not from ill intent, right? Like everyone is basically trying to make sense of the technology and make sure that we don't harm people, right? With like in past deployments, past wide deployments of tech, and so you know, staying engaged, like staying informed first and foremost, and then staying engaged and being able to be a sounding board for policymakers is especially important at this time. Especially if you're in a developing country, like you could be like the one advisor that they're looking for, and because I know for sure in developed countries like they're starved of advice, like they actually don't have enough information to do policy well, and so that's why we've had to engage so much. But I'm sure this is like a problem that's like order of magnitude more difficult to get like proper advice if you're in a more developing nation.
Yeah, I agree. And as someone who really was one of the open science leaders, what is your, if you have to have like one single important advice to upcoming people who wants to lead open science initiatives? And I'm sure in this community are people who are really inspiring to do that. What do you think they should be thinking about, how they should be going about to make their impact in open science?
I would, yeah. I mean, I think there's a lot you could do. I guess what I'm about to say is very biased based on my background, but like I think at a minimum you need to know how to like use a computer well. So what that means is like programming. I think being able to code and like leverage the power of the computer first and foremost, just the computer. Um, leverage the computer to like help you run experiments, like script stuff, right? And make sure you have that foundation for using the technology to do your science, whatever space that is, right? Even if you're doing political science, right? Being able to code, being able to like interpret data, that's part of the job. It's especially important, of course. And then yeah, after that, it's like if you know how to code, you can basically start right away, right? Like I think a lot of folks they hear all this stuff about LLMs these days you need a ton of compute to even start anything. Like I don't think that's true. Like I think you could start at the minimum you could like publish a paper about a really great eval. You could build a really great eval even if you have no compute. um but yeah, like I don't think compute is a necessary prerequisite. I mean, it's necessary, but not. Sorry, it's sufficient, but not necessary. Yeah, that's the way to
Yeah.
frame.
Uh,
So I think you have to be creative. Obviously, like you have to know how to use your tools. You have to know how to be creative. You have to like have the determination to like look for problems, find a solution, and like actually try things. And then all the other research principles apply, right? You have to be like extremely organized, extremely disciplined. You write like document everything. Make sure your experiments are sound, right? Like all these like principles still apply. And then yeah, definitely make use of AI. Like there's a lot of opportunities with AI helping with your research, like deep research for like finding papers that are relevant. So yeah, there's I think it's even though the problem set and the perceived amount of compute has increased, the tooling for doing research has drastically increased from 2017, I feel like.
Yeah. And based on your journey and your background, I would add that find people who are also as crazy motivated as yourself, and like you did with Aidan and Nick, and connecting that also to the theme of this conference, which is collaboration, and finding other collaborators who would you would all help each other grow and learn and build something that can be impactful. Yeah, I think we are at the time for the first section of the conference. Thanks, Ivan. Any last words for the people?
Honestly, I'm just honored to be here. It blows my mind that there's so many people that care this much about like open science. I'm very humbled, and I'm very thankful for all the community support and everything you're doing. Cohere Labs team is excellent, and I'm excited. I'm happy to be here and excited to keep supporting this effort.
Yeah, great. Thanks. It was really great having you on board as well. Thanks so much.